All right, let's dive into the world of enterprise integration patterns. We're tackling a big one today. The book Enterprise Integration Patterns, Designing, Building, and Deploying Messaging. Like a pattern language,
Mm.
like a toolbox, but for connecting systems.
And what's interesting is, even though it gets really technical, the book uses real-world examples. They even made up this fictional company, WGRUS, that sells, well, widgets and gadgets.
Yeah, that's what I liked about it. It makes it so much easier to understand. You can really see these patterns in action, like in a real company.
hmm
So let's talk about messaging. Why is messaging so important for connecting
Well,
systems?
it's all about how applications talk to each other, but they don't have to be online at the same time.
Oh, okay. So it's not like a phone call, more like leaving a voicemail.
Exactly. That's what we call asynchronous communication. And this asynchronicity has tons of benefits, like increased reliability. Messages can be retried until they reach their destination. We also get efficient thread management. Applications don't have to wait for responses. And location transparency. Systems can be physically separated.
Sounds great, but I'm guessing there's some downsides too.
Yeah, of course. It can be challenging for developers, especially those used to traditional request response. Moving to an event-driven architecture is a big change, and you really need to think about error handling. In this asynchronous world, messages can get lost or duplicated, so you need to handle those scenarios.
That makes sense. So messaging is a really powerful integration style, but the book talks about other styles too, right?
Yeah, it does. File transfer, shared databases, remote procedure invocation, each has its own pros and cons. It's about choosing the right tool. File transfer might be great for bulk data, but messaging is better for real-time stuff and for loose coupling.
Right. So each style has its place. Let's dive into the core concepts of messaging itself. Remember, the book uses a postal system analogy.
Yes, it helps to visualize the flow. Messages are like letters, channels are like mailboxes, endpoints are like addresses, and routers are like sorting facilities.
Okay, so if I'm an application, I have an endpoint, like my address, and I send messages by dropping them in the right channel, like putting a letter in a mailbox.
That's it. And those channels, they can be point-to-point for one-to-one communication, or publish-subscribe, where a message goes to multiple subscribers.
Now, this is where I get confused. Messaging is asynchronous, right? But you can still do request reply. How does that work?
It's like sending a letter with a self-addressed stamped envelope. In messaging, we use a correlation identifier. It lets us match replies to requests.
So it's like a tracking number,
Yeah.
even though it's asynchronous. Okay, so we have messages flowing, but what happens when applications use different data formats? It's like trying to order a pizza in Italian when you only speak Spanish.
Yeah, that's a common problem. The book addresses this with the message translator pattern. Think of it as a universal translator, converting data between formats.
Right, so everyone can understand each other. The book also mentions a canonical data model.
Yes, it's like creating a universal language for systems.
So you don't have to translate between formats all the time.
Exactly, it simplifies things a lot.
But creating this model must be a huge task.
It can be, especially for big organizations. But the benefits outweigh the costs in the long run. Think about it. Would you rather struggle with translations or have a solution that works seamlessly?
Makes sense. Okay, so we've covered messaging basics, the postal system analogy, different channel types, and even handling data formats. But I feel like we've only scratched the surface. Messaging can get much more sophisticated, right?
Absolutely.
Tell me more.
Well, imagine a postal system that can sort letters automatically based on content, priority, even the weather.
Wow, so you're saying we're not just sending to a specific address anymore. We can actually route messages dynamically.
Exactly, based on all sorts of criteria.
That's powerful. But doesn't it get complicated to manage?
It can, but that's where patterns help.
Oh, right. They provide a structure for managing complexity.
Exactly. Think of them as best practices.
So even though messaging systems can be complex, these patterns help us build them in a manageable way.
Yes.
Okay, that makes sense. So we have this powerful message router, but what about the messages themselves? Can we do more than just route them?
Of course. Remember the message translator for handling data formats.
Yeah.
We can apply similar transformations to the message content itself.
So we can actually manipulate the message as it's moving through the system.
That's a great way to put it. We have patterns like content enricher and content filter. to add or remove information.
Wow, that's really getting into the details.
It is. And it's where the real power of messaging lies. It's not just connecting systems, it's orchestrating business processes.
Right, it's about making the system work for you.
Huh.
Okay, so we've got routing
Mm-hmm.
and message transformation. What else can we do?
Well, what happens if a message gets lost or duplicated or if the network goes down?
Yeah, real world problems.
Exactly. Thankfully, we have patterns for handling these issues and ensuring reliability.
Okay, good to know.
One of the most important is guaranteed delivery.
Guaranteed delivery. So you're saying a message will always reach its destination, even if things go wrong.
Well, it's not about making the network perfect, but building mechanisms to handle imperfections. Techniques like persistent messaging, where messages are stored on disk.
Ah, so they don't disappear if the system crashes.
Exactly. But there are trade-offs. Persistent messaging can affect performance.
Right. Everything is a cost. Okay, so we can guarantee delivery. But what about duplicates?
That's where the idempotent receiver comes in.
Idempotent receiver. That sounds a bit technical.
Basically, it means the receiver can handle duplicates without any problems.
No double orders or charges.
Exactly.
But how do you even design a system like that?
It requires careful design and implementation using unique identifiers, tracking message status, and detecting duplicates.
Sounds like a lot of work.
It can be, but it's worth it for reliability.
Okay, so we can deliver messages
Yep.
and handle duplicates. But what if a message can't be delivered at all?
That's where the dead letter channel comes in.
Dead letter channel.
It's like the return to sender bin.
So undeliverable messages go there.
Yes. It's a safety net.
And a great way to troubleshoot. Okay, this is getting pretty sophisticated. Are there even more patterns?
Oh, yeah. Tons more.
Wow.
We've only scratched the surface.
Okay, I need a break. My brain is full.
I know, it's a lot to take in.
But it's fascinating stuff.
Is.
We've covered routing, transformation, reliability,
Yeah,
but I'm guessing there's still more to learn.
absolutely. We've only just begun.
Let's continue this deep dive another time.
Sounds good.
I need to process all this information,
I understand.
but I'm excited to learn more.
Me too.
Until next time, then.
See you then. Well, imagine this. A postal system. That can sort letters automatically, based on what's in them. The priority, even the weather. That's what the message router pattern does.
Wow, hold on. So we're not just sending a message to one place. We can route them based on all sorts of things.
Exactly. It's all about dynamic routing. Super flexible.
Okay, but that sounds pretty complex.
It can be, but that's why we have patterns.
Right. To help us manage that complexity.
Think of them as tried and true solutions.
So even though messaging systems can get complex, these patterns make them more manageable.
Absolutely. They're like blueprints.
Okay, I see. So we have the message router, but what about the messages themselves? Can we change them along the way?
Of course. Remember the message translator? For different data formats, we
Yeah.
can apply similar transformations to the content of the message itself.
So we can edit the message as it moves through the system?
That's a great way to think about it. There are patterns like content enricher and content filter to add or remove information.
So we're not just moving messages around, we're actually changing them as we go.
Exactly. We're making them smarter.
Can you give me an example?
Sure. Think about an order processing system. As an order message moves through, we might use a content enricher to add customer information from a database, or a content filter to remove sensitive data.
Okay, so we're not just routing messages, we're manipulating them to achieve specific goals.
Exactly.
This is getting really interesting.
It is.
But what happens if something goes wrong? Like if a message gets lost, or the network fails?
That's a great question. Things don't always go perfectly.
Right, the real world is messy.
And we need to be prepared for that. There are patterns for handling failures and ensuring reliability.
That's good to know.
One of the most important is guaranteed delivery.
Guaranteed delivery. Does that really mean that a message will always get delivered, no matter what?
It's not about perfect networks. It's about building in mechanisms to handle imperfections, like persistent messaging.
Persistent messaging.
It means storing messages on disk.
Ah, so even if the system crashes,
Yeah.
the messages are safe. So
Exactly.
they can be re-delivered.
But it comes with trade-offs, like performance impacts.
Right. There's always a trade-off. Okay, guaranteed delivery sounds good, but what about duplicates? What if the message gets sent twice?
That's a valid concern. And that's where the idempotent receiver pattern comes in.
An idempotent receiver.
It sounds complicated, but it basically means the receiver can handle duplicates without any problems.
So if a message gets processed twice, It doesn't cause any harm.
Exactly.
But how do you design a system like that?
It takes careful design and implementation. You need to use unique identifiers, track message status, and have logic to detect duplicates.
So it's not a simple solution.
No, it's not, but it's essential for reliability.
Okay, I get it. Guaranteed delivery, handling duplicates. What if a message simply can't be delivered?
Like if the address is wrong.
Or the recipient system is down?
Exactly. For those cases, we have the dead letter channel.
Dead letter channel.
Think of it like the return to sender bin at the post office.
Ah, so undeliverable messages end up there
Yes. And we can examine them later.
to figure out what went wrong.
Exactly.
It's all getting very sophisticated.
It is.
Are there even more patterns?
Oh, there are tons more.
Wow.
We've only scratched the surface. There are patterns for routing, filtering, splitting, all sorts of things.
Okay, my brain is starting to overload here,
I know, it's a lot.
but it's fascinating stuff.
It is.
Is there a way to make sense of all these patterns
Well, the book organizes them into categories.
based on their purpose?
Exactly.
So instead of memorizing every single pattern, we can focus on understanding the categories.
That's a great way to approach it.
Okay, that sounds less overwhelming.
It is.
So what are some of the main categories?
We've talked about routing, transformation, reliability, but there are many others.
Like what?
Well, one important category is endpoint patterns.
Endpoint patterns.
These deal with how applications send and receive messages.
Okay, so it's about the interaction between applications and the messaging system.
Exactly.
Can you give me an example?
Sure. One interesting pattern is competing consumers.
Competing consumers.
It's like having multiple workers all listening on the same channel and competing to process messages.
So instead of one worker doing everything, we have a team of workers sharing the load.
Exactly.
That sounds efficient.
It is, especially for high message volumes.
But what about message order? If we have multiple workers processing messages, how do we make sure they're processed in the right sequence?
That's a good question. And there are patterns for that too, like message sequence and strict ordering.
So we can have parallel processing,
Yeah,
but still maintain order when needed.
exactly.
This is all starting to make sense.
It is.
But I'm sure there's still more to learn.
Oh, definitely.
We've covered routing, transformation, reliability, endpoint patterns, and I'm sure there are many more categories.
There are.
But I think my brain needs a break for now.
I understand.
We've covered a lot of ground, and I need some time to digest it all.
No problem.
But I'm excited to continue this deep dive.
Me too.
We'll pick it up again soon.
Sounds good. So we've talked about messaging patterns, routing, transformation, reliability, but there's another important aspect, system management.
Okay, system management. I guess that makes sense. We need to make sure everything runs smoothly.
Exactly. And thankfully, there are patterns to help us.
Oh, good.
One key pattern is the control bus.
Control bus. What's that all about?
Imagine a dedicated channel for management messages, separate from regular application messages.
Okay, so it's like a separate communication system,
Ah.
just for managing the messaging system itself.
Exactly. It gives us a central point of control.
So we can monitor things, send commands, get feedback.
Exactly.
But do we have to manually check it all the time?
Not at all. We can automate data collection using patterns like wiretap and message history.
Wiretap. Are we spying on our messages?
Not really. It's more like passive listening to gather information.
So it's a non-intrusive way to monitor traffic.
Exactly.
And message history is like keeping a log,
Of where a message has been.
so we can track its journey and identify any bottlenecks.
Precisely.
These patterns give us visibility
Yeah.
into our messaging system.
Exactly.
But what if something goes wrong? Are there patterns for handling problems?
There are. Patterns like detour and smart proxy allow us to reroute messages dynamically.
So we can react to problems in real time.
Exactly. And build more resilient systems.
This is all starting to make sense. System management is crucial for messaging.
Absolutely. It ensures smooth operation and reliability.
Well, we've covered a lot of ground today.
We have.
We've explored the fundamentals of messaging, different categories of patterns, even system management. I feel like I have a much better understanding now.
That's great to hear.
These patterns are really powerful tools.
They are.
They help us build better systems.
And solve complex integration challenges.
To our listeners, I encourage you to keep exploring these patterns.
There's always more to learn.
And remember,
Don't be afraid to experiment.
and to share your experiences with others.
We can all learn from each other.
Thanks for joining us on this deep dive.
It's been a pleasure.
Until next time.
Take care.